Hey guys, so today we're going to be talking about Chapter 3, Section 2, which is mean value theorem. And if you need to look for that in your textbook, it is on page 172. So as the broader overhanging topic of the Rolle's theorem, which is more specific than MVT, the mean value theorem just states that as long as the function is, as long as the function is continuous on a closed interval, so say a, b, closed, you have the brackets, and it is a differentiable on an open interval, then then there's a number between the x values of a and b, so there's an x value between the x values of a and b, which we'll call c, within this interval, so that the derivative at c, so f prime c, equals f of a, so the function evaluated at a and the function evaluated at b, over the b value, or sorry, excuse me, this is backwards. Sorry, the function evaluated at b and the function evaluated at a. So, and then the b value, the bx value minus the ax value, which is the end. This is the starting point, this is the end point of the interval. So this is where you get your change, which is what the f prime is. Let's do some examples. First, we'll try a non-real world problem. So let's try f of x equals x cubed plus 2x in the interval -1, 1, closed interval. So let's put this up here so we have room to work. So -1, 1. So first what you're going to need to do is to first find f of a and f of b, because actually we're going to first want to say that this is continuous on -1, 1, and differentiable on -1, 1 open interval. And so, stating that now, we can get that out of the way. We're going to assume that. So we're going to find f of b and f of a. So f of b, in which right here we can say that, just put these in our, substitute -1 and 1 for a and b respectively. So f of b is f of 1, which is 1 cubed plus 2 times 1, which is just 3. And then f of a is f of -1, which equals -1 cubed plus 2 times -1, which is -1 minus 2, which is -3. So f of a equals -3 and f of b equals 3. And after that, we're going to, we already have a and b, so basically we're just going to use the equation. Actually, sorry, we need to differentiate real quick. So for a quick differentiation, f prime of x equals 3x squared plus 2. And so we're going to find f prime of c and then set that equal to this to find the x value, or the c, or sorry, the x value, which is c. So f prime c equals f of a, or f of b minus f of a, so 3 minus negative 3 all over b minus a, which is 1 minus negative 1. So basically this comes plus plus. So this equals 6 over 2, which equals 3. And so now we have f prime of c, so we set 3 equal to 3x squared plus 2. So we're going to erase all of this. So basically 3x squared plus 2 equals 3. So we'll do some algebra. 3x squared equals 1. Divide out 3. X squared equals 1/3. Square root. X equals positive or negative square root 1/3. And it's in the interval, excuse me, it's in the interval -1, 1. So the square root of 1/3 and negative 1/3 are both in, negative square root 1/3 and positive square root 1/3 are both in this interval, so we can just leave it at that this is what the x values that we needed to find by MVT. So let's do a word problem. Let's try a problem with a plane. So we have a plane that begins its takeoff at 2 p.m. Takes off at 2 on a 2,500 mile flight. So after 5.5 hours, so because it's going to be changing time zones, so it's a little confusing. But after about 5.5 hours, the plane arrives, and so the problem is asking you to explain why there are at least 2 times during the flight when the speed of the plane is 400 miles per hour. So using MVT, we need to first write the theorem of itself. So we know that with speed problems like this, the v prime c, which is the velocity, can be used to replace like the f prime c in the equation, because v prime c, all it is position over time, which is interchangeable with the fb minus f of a over b minus a. So let's see, our position is 0 miles at A and 2,500 miles at B, which is our destination. Travel 2,500 miles. And then for time, we had 0 hours. And then we had, that's f of A. And then f of b is 5.5 hours. So for position over time, we're going to do v prime c equals 2,500 minus 0, which is just 2,500, and then 5.5 minus 0, which is just 5.5. And doing that math real quick, we will find that 2,500 miles divided by 5.5 hours is, the VC we're looking for is about 454.55 miles per hour. So knowing that this is like the maximum that he was going, or the plane was going, sorry, we can kind of create a negative quadratic graph using position and time. So this the x-axis is going to be time. So we have 0 and 5.5 hours. So we know that this is 454 miles and somewhere in the middle. So it's asking us to prove that there was, explaining why that there was at least 2 times during the flight when the speed of the plane is 400 miles per hour. So since this is the greatest value, we know that at some time it's going to increase and hit 400 miles per hour, and then also on its way down to 0 miles per hour it's going to hit 400 miles per hour again. So just by drawing a secant line through this, you will see that there's 400, it will hit 400 miles per hour at some point. And so what MVT just proved for us is that that's the secant line and the tangent line, they're parallel. What the MVT just proved for us is that we can write if it's continuous on 0, 5.5, and differentiable on 0, 5.5, then by MVT there exists a C or x value, which is C, such that there's a the interval 0 to 5.5 there exists f prime C equals f of b minus f of a all over b minus a. So basically, with that proof that of MVT, which is the tangent line being the secant line intersects it twice by MVT. The proof of MVT itself says that since the secant line is parallel to the tangent line and it intersects the function like this simple velocity graph, which is only negative quadratic function, it intersects it twice, and it's impossible for it not to. So where it intersects is going to be those values of 400 miles per hour, and that is what proves that it hits the value of 400 miles per hour at least twice during the flight, because this is all we know about the flight based on MVT. But that's all we need, because all the question was asking for is to explain why there is at least 2 times during the flight when the speed of the plane is 400 miles per hour. And this graph, and proven by MVT, of what we used MVT to solve the equation, or to solve we used the equation from MVT to solve this problem. That all proved, this was like the 454, that all proved that the plane hits 400 miles per hour at some point. Thanks so much for listening. See you next time, and don't forget to check chapter 3.2 or ask your teacher if you have any more questions.